In this video I'm going to demonstrate and actually walk through the calculation of the various forecast error measurement summaries. The situation we'll be looking at is we've got the previous 13 periods of observations, and I have the actual data from the previous 13 periods. These are the numbers that actually happened, and next to them I have the values that we were forecasting for each period before we saw the actual data. So in period 1 I had been forecasting the value 98.5. Later I realized the actual value was a 96. In period 2 I was forecasting a 97, and then turns out the actual value was 100. Now these forecasts for period 1 through 13, particularly the forecast for period 1, would have been computed from data that occurred prior to period 1. So when I call this period 1, I'm talking about just the first period of the periods I want to do this forecast error analysis on. There's actual data that occurred prior to this that we would have used to compute that first forecast of 98.5. So my first step is to simply compute the error for each period, and the error is simply the actual value minus the forecast. So my error in period 1 is a negative 2.5. I'll drag this formula down. In period 2 my error was 3, in period 3 my error was 6, in period 4 my error was 10, and so on. Notice some of these errors are positive, and those are cases where the actual data lies above the forecast. I have a positive error term, and some of these errors are negative, and those are the cases where the actual value lies below the forecast. Now I'm going to, in a sense, strip off those negative signs by computing the absolute value of the errors. In Excel I'm going to type equals ABS and then refer to cell D5. Okay? So this formula equals ABS D5 computes the absolute value of whatever is in cell D5 and uses that, and now I will drag this formula all the way down. So before I had a column of errors, some of which could be positive or negative, and now I simply have those same values but the absolute values. The mean absolute error, or some books call it the MAD, mean absolute deviation, is simply the average of those values, the average of the absolute values of the error. So this forecast over periods 1 through 13 is giving me a MAE, mean absolute error, of 6.038. And what we can say is sometimes the forecast lies above the data, sometimes it's below the data, but and sometimes it's off by a lot, sometimes it's off by a little, but on average the forecast is off by about 6. An alternative measure would be the mean squared error. And my first step there is to take the actual errors, again some are positive, some are negative, and I will square the error and drag that formula all the way down. So when my error is 3, my squared error is 9. When my error is a negative 2, my squared error is 4, and so on. Right? The mean squared error is simply the average of these values. Right? The average of those squared errors is called the average or mean squared error, and I have a 46.481. To compute the Mape, mean absolute percentage error, the first thing I do is I take each of the absolute values of the error and divide it by the corresponding actual value. Right? And what that tells me is that absolute error of 2.5, I was actually off by about 2.6%. The ratio is a 0.0260. I will drag this formula down. So in this case, where my actual error was 6, my absolute error was 6, the actual value was 104, I was off by about 5.77% of the value that happened. So I'm taking my errors and computing them relative to the magnitude of the variable I'm trying to compute. And again, the Mape is simply the average of those values. The way I have it described here, it's a decimal. If I format that as a percentage, then we see the Mape as a percentage value. Finally, the root mean squared error is simply the square root of the mean squared error. So I have an MSE of 46.481. If I compute the square root of that number, okay, now I have a RMSE of 6.817. And that's basically how we compute the different summaries of forecast error. Now there's one more measure that we will also look at, and that's the CFE, Cumulative Forecast Error. I have this first column where some of my errors are positive and some are negative. If I just compute the sum of those numbers, right, I get something called the CFE. And what I'm looking for there is to see over time this number should vary randomly above and below 0. Or in other words, the positive and negative errors should be in the long term about canceling each other out. If this number gets too far away from 0, either in the positive or the negative direction, that tells me I have a bias in my forecast. It tells me my errors are more often than not positive or more often than not negative, and my forecast is in a sense off center.